Hi, everybody, and welcome to the Safer Sim webinar series. Today we have researchers from the University of Massachusetts-Amherst presenting their work on bicycle infrastructure at intersections and evaluation of driver behavior. So we'll have Nicholas Fournier, Eleni Christofa, and Mike Knodler presenting their work. And I will let Mike take over from here.
Thank you, Jacob. Good afternoon, everybody. Thanks for joining us this afternoon. Our hope over the course of the next half hour or so is just to share with you some results from one of the more exciting research projects that we've just wrapped up work on. It's a little bit of a different twist on pedestrian and bicycle safety than maybe elsewhere in the literature. So the webinar today is bicycle infrastructure at intersections and evaluation of driver behavior. And as Jacob mentioned, it's Nick Fournier, Eleni Christofa, and myself. So before we jump in, just a little bit of background about SaferSim and what SaferSim is in particular. So SaferSim is a UTC program, stands for Safety Research Using Simulation. The consortium is made up of 5 member universities, led by the University of Iowa, also with the University of Wisconsin, UMass-Amherst, University of Central Florida, and the University of Puerto Rico at Mayagüez. Central to each of the teams or the members of this consortium was traffic engineering experience coupled with human factors experience and the ability to carry out simulation, either micro simulation or driving simulation. Just a little bit of background by way of where we are. Usually, as soon as we say that we're from Massachusetts, everybody's first thought is Boston. You see Boston over there on the eastern part of the state. But Nick, if you can go ahead and just toggle on a couple more. We are located out in the western part of the state, out in Amherst, and just a couple snapshots from campus so that you can picture where we're at. So a lovely rural campus that you're an open invite. You're all welcome to come and check it out anytime that you would like. So just, I know I've always found it a little bit of a pet peeve to not be able to put a name with a face as you're listening to a webinar with folks participating. So pictures of Nick, Eleni, and myself, we're part of the SaferSim team out here at UMass. When we think about the abilities of our contributions to the SaferSim consortium, oftentimes the first thought is the Arbella Insurance Human Performance Lab. Within our driving simulator lab, we have 4 different driving simulators, including a couple of different RTI systems, an STI system, a MODAT system as well. Nick will describe the simulator that was used in this experiment in a bit more detail. And we also have an active safety program. As part of that safety program, we have a crash data warehouse. As part of that crash data warehouse, we have large sets of crash data, crash and safety data that we're able to integrate into our research. Now, this particular project, Nick's going to describe in greater detail the motivation, but I guess the easiest way to explain the motivation for this particular experiment is that we have the bicycle community and we have bicycle infrastructure, and we've done varying degrees of safety evaluations with respect to bicycle safety in terms of looking at both crash data, cyclist understanding, and the like. But one of the questions that we were really curious to answer is, when we add this bicycle infrastructure, what is the impact on driver performance or driver behavior? So looking at the impacts, particularly of bicycle infrastructure on driver behavior. And that's really what Nick's going to spend the next 20, 25 minutes talking about, is the results of our experiment and the setup and design. So I should have mentioned, if you have any questions, you should feel free to use the chat bar in the lower corner of the window. We'd be happy to answer any questions in real time as we're making our way through the presentation. And then at the end of the presentation, there'll also be more of a Q&A, an opportunity to open up everybody's mics and allow you to all talk and answer questions and participate in the conversation at that point as well. So with that, I'm going to go ahead and turn it over to Nick to describe the current work.
So I'm Nick. I'm a PhD student at UMass, and this is what I've been working on for the past, I guess, year or so. The purpose for working on this is to try to make cycling safer. As a cyclist myself, this is pretty near and dear to my passion. And so in recent years, we've seen a huge increase in cycling across the United States. there's been a 60% increase on average, and that's accounting for all small towns and suburbs. So if you look at just cities, that stat becomes more closer to 100%, and in some particularly friendly cities, it's 200% higher. A lot of that has to come to do with increase in bike facilities, namely bike lanes. But unfortunately, these bike lanes don't necessarily go through intersections, which is a travesty considering that the vast majority of crashes happen at intersections. In Massachusetts alone, intersections account for 75% of all bicycle collisions. So one of the biggest causes behind these crashes are called right hook collisions. These are essentially when a vehicle trying to make a right turn at an intersection cuts off or sideswipes or veers into a cyclist. This usually happens when a cyclist is either in their blind spot or a driver's not looking for a cyclist, or sometimes the driver will think that the cyclist has to turn right with them. And these are happen all the time, and they can be deadly to cyclists. The second, a little bit less common crash is called a left hook collision. These are just as severe, if not worse. This tends to happen when a car at, say, an unprotected left turn, they're trying to wait for a gap to happen from oncoming cars. They're looking for cars coming, they're looking for that gap, but they're not looking for cyclists coming through. And so when they go to make that turn, they crash right into a cyclist. And so it's an extremely dangerous situation. Sometimes this also happens because a car, say a truck, is moving slowly and it blocks the line of sight. So that's another thing to consider. These tend to be look but did not see situations where cars are looking for other cars and not necessarily this silent, smooth, speeding vehicle coming towards them. So some of the treatments that we looked at, these are pretty common. I'm hoping that most people have seen these before. So bike lanes, these essentially perform two functions. They designate a space for cyclists on the road, and they inform drivers of this space, and they let drivers know that cyclists will be present on the road, and they need to give them that clearance. They're pretty popular because they're simple, they're cheap, and they're effective. The problem with bike lanes is that they don't necessarily offer any physical protection from cars, and that's accounting for parked cars as well. So dooring is a huge problem when people open their doors or they pull their car out without looking. When bike lanes do have physical separation, they're called separated bike lanes, or more informally, cycle tracks. We're not going to look at cycle tracks in this experiment because they are a study in and of themselves. Probably the biggest issue with bike lanes is that they tend to appear and disappear suddenly on roadways, especially intersections. They'll be designed up to intersections, but not through an intersection. So this is exactly where cyclists are most vulnerable because there is no bike lane or any other facility for bikes in this intersection. So another treatment which is pretty common are sharrows. They kind of operate on the opposite strategy of bike lanes. They basically, instead of separating out traffic, they say, all right, let's mix everyone in together. You all have to abide by the same rules. The idea behind sharrows is that, all right, it's a low-speed road with low volume, and we can extend the benefits of mixed traffic through the intersection. And again, they are simple, cheap, and effective treatments. The problem with them is that they're intended for narrow, low volume, low speed, quiet, residential likely roadways where bike lanes don't really make a lot of sense. But as a problem, they tend to get on roads that don't really have enough room for a bike lane. Engineers will tend to just kind of put them in there and say, well, it's better than nothing. So a lot of times they often work better in theory and not necessarily practice. So I saw a question up in the chat box.
Dev has a question here. They're asking, are bicycles required to have daytime lights to enhance their visibility, especially during left hook situations?
To my knowledge, it depends on the jurisdiction, sometimes even by city. I do know that most places will require front headlights, but personally I find that having a rear red light is more important. But daytime-wise, I do not think it's enforced, to my knowledge. But all right, so I'm going to keep going. Hope that answers your question. But I do think that lights would probably help mitigate that. Bells are also nice to have too. Some audible. So the moving from mid-block treatments, we're going to look at intersection treatments. One of the really popular ones that helps mitigate this right hook collision is called a merge lane. Not to be confused with the mixing zone. Mixing zones are usually used for separated bike lanes to help reintegrate cyclists back into traffic. So some of the problems with merge lanes is that they essentially just move the collision point away from the intersection. The idea behind them is that, well, if they're getting hit from a right hook, let's put the bikes on the left side of the car so they won't get hit. And they usually work pretty well, but a lot of times, like I said, it just moves the collision point back away from the intersection where cars are moving faster, and it just creates a more severe crash situation. Sometimes it can be confusing. I've had people ask me, well, I thought I wasn't supposed to cross the solid green paint. And so what they end up doing is just going all the way to the end of the intersection and making an illegal right turn. They can be really stressful. So sometimes I'll see them on these like 3 or 4 lane roadways where cars moving like 30 or 40 miles an hour. And if anyone has ever done that, it's terrifying. So it's extremely stressful for cyclists. It's a little bit like Frogger in real life. So last, and this is kind of a little bit less common, but still is becoming more and more popular. It's essentially an advanced stop bar, so that it allows cyclists to congregate ahead of the traffic column at a red light. The idea is that it makes the cyclist clearly visible because you're obviously right in front of the car, and it also helps cyclists make a left turn because that's a very difficult maneuver to make as a cyclist. The problem is that sometimes drivers aren't aware of bike boxes. They don't think that they need to stop there when there isn't a cyclist present, and the biggest thing is that they offer no use when it's a green light. It only works when there's a red light. I don't know where exactly the history of these treatments came about, but I do know that they've been used in some Southeast Asian countries where mopeds and scooters are really prevalent, and they'll let them congregate and clear the intersection before the automobiles can go through. So I think that's likely where it kind of evolved from, but I can't necessarily confirm that. So the apparatus that we're using is the driving simulator. It's a full sedan. It's I believe a 1990s era Saturn. It has all the controls have been reconnected to be connected to the computer, and there'll be 160 degrees of viewing screen in front of them that will display a simulated roadway. So the participant will step into the vehicle and drive the vehicle as if they would normally be driving a car. The benefit of this is that it allows us to capture a level of detail that is not normally achievable in the field. So we can track their speed, position, lane position, acceleration. We can even track how hard they're pressing the brake or how fast they're turning the steering wheel. So it has extremely high resolution detailed data capture. I think it captures data at 60 hertz, so every 1/60th of a second. These are the treatments that we simulated in the simulator. There are 16 intersections, one for each treatment. So they'll say they get to a bike box, they will hit each bike box 3 times, one left, one right, and one through maneuver. There are 2 scenarios. They're identical, but one of them is in reverse. So half the participants drove the same scenario, but in reverse to help counteract any sequencing effects that might have occurred. If anyone notices that the signals in this are not MUTCD compliant, I will assure you that I did fix them in the final simulation so that they are MUTCD compliant. And the the sky in the background, this is just in the builder, in the developer. That's why it's just blue. In the simulation, it's actually a little bit more realistic. It has a skyline and some clouds. So the traffic in the scenario is pretty light. Most of the traffic's in oncoming direction. I tried to make it light enough so that the participants wouldn't get stuck behind a simulated vehicle. And I also wanted to make it so that they're always at the head of the column at an intersection. I didn't want them to be third in line. There are bicycles simulated in there, but they're going in the opposite direction because I didn't want to influence their behavior. But I wanted to say, hey, there could be bikes in this, so just look out for them. But they weren't directly interacting with them. They also hit a red light at every single intersection to show a consistency across. So yes, they hit 16 red lights. We also used an eye tracking device. So it's basically a pair of goggles with a mirror and two cameras, and it integrates their pupil movements with their perspective, and it turns it into a crosshair, as you can see in the picture on the left. And that way we can record where people are looking, which is extremely useful because we can see, did they even see the treatment, and if that influences their behavior and for how long they looked at it. We also use some old technology, just a paper survey. We had two surveys, a pre-study questionnaire and a post-study questionnaire. The pre-study was basically just basic demographics, age, gender, driving history. We did not mention anything about bicycles. We didn't want to bias the study. The post-study questionnaire then asked how often they biked and for what purpose. We also asked what their familiarity was with each of the treatments and their preference, which was really important. We could see, had they even seen a bike box before, a bike lane. Just some broad statistics of the participants. We did manage to achieve a perfect even split between male and female, but given that we're in a college town, most of the participants were probably pretty young. The vast majority of them were between 18 and 21. I think that might be reflected a little bit in their driving behavior. Most people drove less than 50 miles a week. And I was happy to see that there was a pretty good spread of cyclists among the group. It was a bit bimodal, so it was either like people were cyclists or not cyclists. There wasn't anyone who just casually bikes once a month. So it was a bit interesting to see that. So the purpose for the questionnaire, which I think separates this from a lot of other studies, is that it allows us to compare the results from a survey on who people were and how they behave, and their background, to how they behaved in the field. So we did more than just say, oh, we had a 50% compliance rate. We could say, all right, well, of that 50% that didn't comply, who were they and why not? So it gave us an extra level of detail to start beginning to formulate some of the causes why something didn't work. This is kind of just a rough explanation of the variables that we looked at. So for bike lanes, we looked at speed and lane position, and then compared that to the results in the questionnaire. The bike box, we looked at just stop position. Merge lanes, we looked at crossing speed, crossing position, and eye glances, whether they checked their mirrors for bikes. Sharrows were a little bit tougher since they weren't directly interacting with bikes. We could only really compare approach speed. And then, of course, we used no treatment at all as control. So just looking at the results from average speed, we found that 80% of the participants were very familiar with bike lanes, and 100% were at least seen them or somewhat familiar with them. So that's good. That means that most people know what a bike lane is. The bad news is it didn't affect anything. People just drove however they wanted to drive. I'll point out that there's a pretty big spread in speed here because we did not post a speed limit because we wanted to see what people drove naturally. So that's why we have some people going almost 60 miles an hour while others tenderly moved along at 25 miles an hour. So it doesn't look good for bike lanes, but when we break it up, cycled rarely, there was a bigger spread. People tended to drive much faster. I don't know you can see that there's a pretty good pairing between bike lanes and no bike lanes, but it would seem that people that don't bike drove a lot faster than people that do bike. Looking at lane positioning, there was a consistent shift over, but it was found to not be significant, and it only equated to about 3.5 inches. So it's pretty negligible, the shift over that people made in the bike on the drive lane from the bike lane. And so looking at this again, comparing for reported cycling frequency, we found that those that bike more frequently shifted their position more to the left overall, whether there was a bike lane or not. They tended to be away from the shoulder, which is interesting. So one can speculate that once they saw that there were bike lanes in the scenario, they just universally shifted over, or maybe they just tend to shift more to the center of the road. Merge lanes, this is a little bit tough to come up with definitive conclusions from. we found that 30% of the participants responded as unfamiliar or very unfamiliar, so they had never seen one before with merge lanes. This plot is essentially an XY plot of their position, and the color represents their speed, but it's hard to discern. But essentially what it shows is that the majority of people just casually veered across the merge lane before making the right turn. This is a little scary because only 10% of drivers even check their mirrors for any other cars or bikes. So the next time I'm going through one of these, I think I might think twice. Intersections in general, the approach speed, we want to see if there's a difference between any of the treatments at all. Did it affect people's approachment? So overall, we found there was really no significant difference, whether there was a share or a bike lane or nothing at all. People just approached the way they would normally. I suspect maybe if there's a bike involved, they might approach differently, but this does not bode well for sharrows and the idea that sharrows affect passage through intersections. Bike boxes are very promising though. Even though only 58% of participants responded with being familiar with bike boxes, the majority of people said they had never seen them before, essentially. Yet, despite that, almost 3/4 yielded properly behind the stop bar. And then when we break that into groups based on familiarity, we see that if they'd even seen them before, they used it correctly, and it was only the group that had never seen one before that did not comply with the bike box. So I want to look at just that group that didn't comply and see if there was any sequencing effect. So maybe by the third time, they figured out how it worked, and there was a little bit of that. So we did find that the first time, a huge chunk of people did not use the bike box properly, but by the second time, most people understood, oh, okay, I need to keep this clear. There still were some people that did not, but overall, people figured out what their purpose was pretty quickly. This is really promising. This suggests that the effectiveness of the bike box is not necessarily static. It can be improved through either education or some sort of information that we can disseminate through the public. So now at this point, you're probably wondering, well, what about the eye tracker? So the eye tracker, to be honest, it didn't collect as many exciting results as we had hoped. Participants didn't really gaze at treatments. It wasn't anything we could create a really exciting heat map out of. They mostly just looked at it for a split second and went back to driving. They just kind of went along the roadway, looked at it, glanced for a split second, and went back to going what they were doing. So for that reason, we didn't really record gaze duration because it would be very difficult to find a difference between, a millisecond or so. But what we did do is go through and count up all the participants that did make these eye glances at treatments. And so we saw that the vast majority of all subjects did look at the treatments. So that's promising. What was interesting, though, is that a lot of times people would look at the treatment only the first couple times that it made an appearance. And then even if it did pop up again, they wouldn't really look at it. So that's not necessarily bad. That just means that they've recorded it, they've understood what its purpose is, and moved on to driving and not getting distracted by it. So that's a good thing, considering a lot of these treatments, people criticize that they're distracting for being painted bright green. So I would argue that they might not be bright enough. This is kind of an interesting result just on bike lanes. When we split it up based on cycling frequency, we found that monthly cyclists were more prone to look at the bike lanes than their peers for whatever reason. We suspect that it may have to do with monthly cyclists are more cautious and aware of bike facilities than their non-cyclist peers, but aren't quite as battle hardened as the daily or weekly cyclists. This is purely speculation. It's hard to come up with any conclusion, but it is an interesting result. And if we look back at the previous plots, we could see that monthly cyclists were always kind of outliers. And last, we had an open response on the surveys, just as good faith. And I was surprised to see that almost everybody responded, although all the responses basically said, we weren't really sure how to use it because we've never seen it before. So no one really said, I hated this, but they said, I wasn't super confident because I never had been taught this in driver's ed, or similar statements of that type. So things that we gathered out of this, unfortunately, merge lanes and sharrows we did not gain a lot of significant results from them. I think these require studies in and of themselves, particularly at intersections. Merge lanes, they can have a whole many different type of configurations and scenarios that could arise, particularly if we have a bicyclist present, that we need to try to elicit those kind of reactions out of drivers. I don't think this study fully captured that type of information. I think there are a lot of future studies that can be done to improve the results out of that. Some other future things that we do want to really study are protected intersections. They basically are a new type of, they add these corner islands to an intersection that allow cyclists to make protected turns through an intersection. So they're perfectly suited for separated bike facilities. So that way you can continue the benefits of separation through the intersection without risking reintegrating bicyclists at an intersection. They've been more commonly called Dutch intersections, and I think there are 2 or 3 in the US currently. I think most are still under construction. And then another study that we would like to do is advisory bike lanes. They're basically, you add kind of soft bike lanes that cars can get into as well, and you remove the center line. So this is perfect for roads that are low volume and are narrow and aren't quite suited for sharrows or bike lanes, somewhere in between. So I saw there's a chat box. Could you repeat the question?
Sure. Deb was asking if we had a record of comments made by the cyclists and drivers by way of suggestions to make their interactions safer. So backing up a slide, looking at the open response questions.
I have a record of their open responses. I basically coded them, clumped them together based on their type. But I did there wasn't a ton of behavioral responses. But I did have one person actually say, I should have been taught this in driver's ed. So
well, I think that's actually a great question too, because I think, building on what you're saying there, Nick, that's certainly something that could be the focus of a driver bicyclist interaction study.
yeah. Which I guess segues into autonomous vehicles, because me as a cyclist, whenever I approach an intersection, I always try to make eye contact with the cars, and if it's a self-driving car, there's really no one to make eye contact with. So how do we mitigate that? Some people are saying, well, if you could turn your cell phone on to have some sort of app, like a neon vest of the digital age, but I'm afraid that might add a whole other set of problems. But yeah, that would be an excellent study to try to figure out expected behavior of cyclists and drivers between the two, because I know a lot of times what's a normal behavior for a cyclist might be confusing to someone who's not used to driving with cyclists, or vice versa. So moving to conclusions, essentially the effectiveness of a treatment is largely influenced by a driver's experience as a cyclist and their understanding of treatments. So what this really means is a safety in numbers phenomenon. The more cyclists in a community improves the safety of cyclists overall, because people have a better understanding of what is required of cyclists and what is required of being a driver. So how to improve that? Well, we could add sign instructing drivers how to use these new treatments. We can also instruct cyclists how to use these treatments. Sometimes it can be confusing for them as well. Public engagement campaigns and news publications, other activities of that sort to try to get people involved in these treatments instead of just putting them up in the middle of the night and hoping that they work in the morning. And incorporating driving with cyclists into driver's ed. Overall, this highlights the importance of creating and promoting a culture of bicycling in a community, not just adding static infrastructure and hoping that it works. I think it's a little bit more something in between. So now I can open it up to questions for anyone. chat box.
And let me chime in and add here. Apart from the next couple of minutes, people should feel free to email Nick, Eleni, myself at any point. We'd be happy to take any questions that you might have over email, following up on today's webinar as well.
Yep, I can share my email address. It's on the slide.
So Nick, I don't know if you can see the question box yet, but it was talking about the typical dimensions of the protected intersection of the Dutch intersection. I think I'll take a stab at it first, but certainly Nick, jump in if you'd like. The answer is there's no typical dimensions because they are also varied. Some of the initial the conceptual drawings make them look quite a bit larger than they actually are. However, when you do visit some European cities, you find that they're actually quite a bit smaller and fit within the context of the intersections, the smaller intersections that might exist there. If you want to realize all the benefits that are associated with the protected intersections, I think they do tend to be a little bit bigger, but that's okay because that's where, at those particular intersections, that's where they're most advantageous.
Yeah, I remember I spoke to somebody at one point about coming up with standards for them, and I think it depends on the goal that you're trying to get across. If you're trying to do a full-fledged one, one of the key components is having enough space between the island and where the bicyclists will be moving, so that one car could queue up to allow the cyclist to move through while still not impeding traffic. But at the same time, I think the important component are the corner islands. And I think they're especially important for separated bike lanes because you're essentially moving cyclists out of the intersection instead of through the intersection. And so if you were to have a bike lane with corner islands, you would run the risk of cyclists just going to the left of them and going through the intersection anyway. So you have to kind of find that fine line between getting the cyclist to move a direct shot through it while still being out of the intersection. It's still an emerging design, and I think it's interesting that in the Netherlands they just kind of put them in there, and it's not necessarily an individual design type. It's just they found that it works, and so it's still kind of evolving. But I think one person who's pretty knowledgeable on dimensions is Nick Falbo of Alta Planning, if you've heard of him.
So next question here. So Joe's asking, can you discuss how you would design a scenario with simulated bikes, i.e. how, when to time their motion relative to the driver? Joe, to be perfectly honest, the introduction of bicycles within the simulated environment would lead to a whole another fun set of variables that we would need to consider. Off the top of my head, the first thoughts would be related to the positioning of the bicycle and then the adjustments of the bicycle. So we would predominantly try to stage the scenarios in such a way that we create intentionally so both the right hook or the left hook crash scenarios. So we would intend to have a scenario where a driver in a vehicle would pass a simulated bicycle, but time it in such a way that the bicyclist would be arriving at the intersection at the exact same time that the driver would be getting ready to execute their turn. Trying, of course, to put the driver or the bicyclist in the blind spot of the driver so that we're able to detect how well they're able to predict the presence of the bicycle or make use of the particular facility to identify the bicyclist.
Yeah, so definitely just kind of adding a trigger that as the subject vehicle passes, the bike would kind of jump out into harm's way almost.
Right, and we would speed up and slow down the bicyclist as part of that simulated environment to replicate that.
And there would be multiple scenarios depending on whether where the bicyclist and the vehicle are turning.
Yeah, and part of the challenge with those types of scenarios, as you know, Joe, from your simulations, is sometimes when you're creating high crash threat scenarios, you almost get one shot per subject driver, because once they end up in a scenario that would be likely to result in a crash, we're not able to replicate that scenario again. So one of the things that we often do is try to create the threat or the presence of the threat without the actual threat materializing itself result from that.
I'll take a crack at that next question.
Yeah, sure.
So to my knowledge, there isn't necessarily a mandated minimum or maximum for Sheros. NACTO is a really great resource. They have a lot of good parameters to kind of go by. Otherwise, as far as speed limits go and volume, it kind of depends on the roadway. But I think in general, you have to think if you're a cyclist, cyclists tend to go an average about 12, 13 miles an hour if they're cruising. So even 25 miles an hour is still pretty fast. So you have to make a balance between, well, is the speed limit higher, but it's very low volume so that cars can pass cyclists? Or in the opposite sense, is volume high, but speed low enough that it's not a problem, that people don't feel like they need to pass cyclists? So I think that's kind of the trade-off, if that makes any sense. So essentially, if you have higher volume, I would err on lower speed. But if you have a higher speed, then you would probably need to have a lower volume. But in general, I would try to hit as close to the speed of a bicyclist as you possibly can.
So next question here is from Joe. Do you think it would be helpful to use connected bike/vehicle simulators? Joe, I cannot say yes out loud enough as an answer to this one. I think that would absolutely be the best way, and even better would be able to test both a bicycle operating in a same virtual world as a driver and studying the nature of their interactions. So yes, definitely.
Sure. Let me go back to that. Can you still see my screen?
Yes. Yep, we can.
Okay. So the approach speed was tough. I basically I plotted the profile of the speeds through the intersection, and this is in terms of just distance traveled, not relative distance. So that's to account if they made a left or a right turn, not going through the intersection as well. So I basically tried to find what was the maximum difference between all the speeds, and I found that even the maximum difference was still within non-significant range. It didn't go above the threshold. I think this definitely needs a lot more review, to be honest, especially if there's a cyclist present. So for Sheros, say there's a red light and there's a Shero and there's a car approaching, I'm sure that would dramatically change their approach speed. And if you can look closely, you can see a lot of time there's some fine lines on the bottom of the curve where cars would approach and slow down preemptively and try to wait for the light to turn, if anyone's ever done that. Of course, they quickly realized that they had to go within a certain distance before the light would change. But basically, the variables I used were the maximum difference speed for each treatment compared to each other. I used an ANOVA test. The protected intersection. So, can you guys see my mouse by any chance?
And see your mouse, Nick.
Okay. Let's go down to the end. Oh, that didn't work. Okay. So anyway, the the protected intersection, it's almost like, imagine the bikes have a rotary or a roundabout, and the cars have a four-way intersection. So as a cyclist would approach, say there's a red light, they queue up in this little safety zone, and then when the light changes, cars, if they're making a right turn, there's enough room for them to see a cyclist in clear view as they're making this right turn, and so they have enough time to stop, and then the cyclist can go. So if you're a cyclist making a left turn, instead of going in the middle of an intersection trying to make a left, you go and they call it banging the corners, where you go across and then you make a left up here rather than through the intersection. And so the idea is that it offsets the turning, it makes a larger turning radius for vehicles so that or I guess a tighter turning radius so that they are forced to slow down more, and it positions cyclists more in the visible line of sight. So I think they're more suited for bigger intersections than the one I have displayed here. I think it would be better, say, if you had 2 lanes, but parking has definitely helped to offset that. Yeah, the animation makes it much easier to understand. They also aid well to bicycle-specific signals. So say you want to just clear the intersection for cyclists, you give them a couple seconds head start or their own phase. It's kind of just like the next echelon of bicycle infrastructure at intersections that kind of continue the separation through the intersection. So do we have any other last questions? Looks like someone's typing. That is a good question. I think it may go both directions. I think coming up with new infrastructure and better infrastructure and innovative infrastructure is better for the transportation world for bikes overall. But at the same time, like, we do want to keep things simple and easy to understand and intuitively to understand. Ideally, we don't need to have to take courses on understanding how to get through an intersection. So there is a balance between the two. But I think this goes back to understanding what it's like to be a cyclist as a driver as well. I think it can be, a lot of times I find people don't necessarily understand, like, why are they coasting, or instances that there's certain kinds of behavior that cyclists do. Like, we don't have brake lights. You can't really see when we're stopping. But yeah. Right. I think it'll be a case of the right tool for the job, not necessarily one size fits all. So it's probably somewhere in between.